So it's a good afternoon and welcome. This afternoon's session on From Zero to Data Insights using HDInsight on Microsoft Azure. Welcome, my name is Peter Myers. As an announcement, this was originally scheduled to be presented by Brian Mitchell, who unfortunately has fallen unwell, and I've stepped in at last minute to help out to continue delivering this session. I have a slightly different take on this topic. My background is more in conventional and self-service business intelligence. So when I talk about big data, I'm thinking about it more in the business intelligence scheme of things. I can talk practically about the big picture, but you'll notice a focus when I talk about this, even with my demonstrations, that they're business intelligence oriented. All right, so I'm a SQL Server MVP. I've worked with Microsoft Business Intelligence products for well over 15 years. I come from Melbourne, Australia, and I'm very happy to share this introduction from zero to about big data today. So by show of hands in the audience, who here is already working with big data? Already working with big data. You come to a session that is zero to big data. The concept about zero is typically that we'll take you from zero background. You're most welcome to stay, and we definitely want to tell you about how Microsoft are working in this space. We're going to work with the very basics about what big data is and build up, describe scenarios, and a few demonstrations that are going to show how we could work with big data in our solutions. So we'll introduce terminologies like big data, Hadoop, and Microsoft Azure HDInsight. We'll describe what the big data process is, how it happens. We'll see it happen in a demonstration. We'll talk about various big data scenarios and hopefully inspire you with what you may be able to achieve with your own data and big data technology approaches. So let's start with the very intro. What is this all about? Why do we have a new way to store, process, and query data? Well, the fact is, we are all contributors to this mass collection of data, whether it's our tweets, our Facebook entries, our phone calls, our very presence even here in this room is being recorded somewhere. And the fact is, we're recording larger volumes of data than ever before, and what that means is there is new opportunity to discover insights and to do things better. So whether it's device explosions, social networking, sensor networks, ubiquitous connections, and in combination with cheap storage, we're just storing it these days. It's less likely to find that DBAs are concerned with archiving data. It's now inexpensive to continue to storing it. Whether we know we need it today or not, to lose it, it's irreplaceable if we do go ahead and drop that type of data. So even with the recognition that maybe we need it, we're usually happy just to continue storing it. So this introduces an entirely new challenge when it comes to the storage and querying of data. And when I go to Wikipedia to get a basic definition, this is what's come back. Big data is a collection of data sets that are so large and complex that it becomes awkward to work with by using on-hand database management tools. So the old way of doing things may no longer be practical or most likely no longer economical. Difficulties will include the capture, storage, search, sharing, analysis, and visualization. And that's where I come in, the last two. How do we analyze and visualize masses of data? And how do we discover insights even before we consider visualizing them? So when we talk about big data, it's very common to talk about the three V's, beginning with the most obvious. Big data lends itself to an understanding of big volume. So sheer amounts of volumes staggering compared to what we were doing even 10 years ago in terms of storage. Variety. So data doesn't always come in convenient tabular format. That's a shame. All right, so we have all types of structure, whether it's hierarchical or even whether it's just lots of ones and zeros, binary data. Nonetheless, it's data, it's been captured, it's been stored for a purpose, and it opens up the challenge for us then to make sense of that. Traditional database products struggle at this point to work with non-tabular forms. Velocity is the next consideration, that this data, by definition, if it's big data and we have large volumes of it, it's probably being accumulated at a fast rate. Is that a fair deduction to make? At this case, it means that the data could be coming at you so fast that it may be impossible or very expensive hardware-wise to be able to capture that as it's happening. And so Microsoft already have a solution for this before we even think about big data. What do you do when you have such large volumes of data coming at you at speed and yet you need to make sense of it? Anyone heard of complex event processing? Stream Insight is Microsoft's implementation of a complex event processing engine. So what you can do is streams of data, you could capture windows of it and summarize it every second. That's the average that's coming through. So you could use complex event processing to go ahead and make streams of data practical small volumes to store. But the point that I'm making here is the velocity angle may well lend itself to a big data scenario as well, as we'll talk about in this session. So there's the 3 V's that are commonly used to introduce why we have this new way to capture and store data. Plotting here against size and storage and therefore cost. We can see here that the traditional systems, ERP, CRM, they fit comfortably still within a SQL Server instance. They might grow to the gigabytes or even to the terabytes, but they're still manageable and economic to store in this way. Moving up, the Web 2.0. When we think about classic examples, and it's always good to think of extremes, Amazon, you can even think about the number of transactions that are being processed a second. And you might automatically think, well, yes, these would be orders that people are submitting. There's actually far more ambient data that's being collected when you're visiting Amazon. Are you aware that every time you hover over something or click, or even the duration between clicks, all this data is being collected? And it's mind-boggling to think what is being collected and the volume of that data simply for that single 5-minute experience you had while shopping. So with the advent of global retailers, as a great example, not just their commercial transactions, but ambient data being collected is resulting in petabytes. Then moving right up to the Internet of Things, the classic would be to talk about Facebook. Can you imagine there what's going on with the volume of data? And this is the new challenge today. Different shapes of data, large volumes of data, and yet the business still has a need to make sense and to understand what that data represents. Common scenarios, sentiment, what are people feeling? We'll talk about this in more detail in a minute. Clickstream analysis, what is going on with our web applications? What is being clicked on? What are the trends from this? Sensors, time and place information, server logs pumping out volumes and volumes of information, and text data, whether it's emails, Twitter, blog entries. New opportunities. So that's where we lead to here. We can now respond to questions that we just couldn't respond to in the past. And I'd like to focus on this first one here about social analytics. It's quite a reasonable question that a business might say, well, what's the social sentiment of my product? You know, SQL Server 2014 was recently released. Microsoft may be interested to know what people feel about it. So what do you think are the available data sets that could help them answer this question? Where would we start looking for sentiment, feeling about what people think about our recent launch and marketing campaign? Twitter, okay, so clearly people using hashtags, we can catch these, we can understand what people are saying specifically about the launch. What else? LinkedIn, okay, so LinkedIn. Anything else? Yammer, blog comments. Does Facebook come up here? So I want to just talk about Facebook for a minute, because I often ask my audience, you know, who's on Facebook? And by show of hands here in this room, who does have an active Facebook account today? So as I would expect, you know, at least 80, 90% of you. And you think about Facebook being this amazing service that doesn't cost you a cent. Do you ever reflect on why this service is available at no cost to you? You are the product. The way that I term it is that you're actually the data entry people for Facebook. You see, the real business and why Facebook has such a high share value is because they sell commercial data sets. And Microsoft may well approach Facebook and say, we really want to know how successful our campaign was, have we hit the demographics that we're looking for, and they would request a set, and within privacy limits, Facebook would provide that. Not only would they provide maybe status updates that reference the term SQL Server, they would provide demographic summarizations. And then we could take all of this data from Facebook, from Twitter, from blogs, from LinkedIn, and then we could start to make some sense of it. And how do we start to make sense of masses of text data? And that becomes the next challenge. Having identified, captured the data, This is where we can use newer algorithms that can, by association, understand intent from words. So that's quite an interesting science in its own right. I think SQL Server is fantastic, may well be scored at a +10. And then I think SQL Server is not fantastic. It's amazing how one word in English can turn everything from a +10 to a -10. So we have algorithms today that can sift through masses of data and score either as a positive, negative, or neutral if it cannot be determined. And so what we're then arriving at is a point that we've got demographic information related to these scores that then can be aggregated, averaged, to allow us to then slice and dice by geographic region, by gender, by age group, to understand what people are feeling about my product. And that's pretty close to how sentiment analysis works today. The challenge with this is interesting, complex data sources, and then the science behind how we extract meaning. The next example, responding to live data feeds. How do I optimize my services based on patterns of weather, traffic, and so on? We have on this planet today tens, if not hundreds of thousands of weather stations that are constantly collecting information. I just think one such example would be airlines that are looking to take advantage of the best wind streams. And so that's got to be real up-to-date data and being collected from an enormous number of sensors, satellites included, with imagery data in there, and the ability to make sense of that for the benefit of reducing operating costs with fuel. How do I predict future outcomes? Well, the whole topic of data mining fits very, very well. I talked about data mining this week, whether you're data mining relational database on-premises sources, that's fantastic. But now the ability to look for patterns across other larger sets and more interesting sets of data, even binary data. You know, the facial recognition technology is data mining. And that's quite amazing when you think there are now algorithms that can, with reasonable accuracy, track people walking through a city. And that's where this technology is heading and is arriving today. So big data is enabling the storage, the processing, and the ability to ask and have questions answered. We can then introduce the technology behind this. And this yellow elephant, wherever you see it, and I was very confused when I first saw the elephant. I saw absolutely no correlation between big data and an elephant. And then one day the light went on that I guess big animal and big data do go hand in hand. Am I wrong with that thinking? I do know the background, and I can share that here, that one of the pioneering developers' child had a toy elephant named Hadoop. And I guess just one day they were wanting a name for a project and it stuck. Does anyone know a better story than that? Okay. Well, what is Hadoop? It's all about big data. It's a set of open source projects that transform commodity hardware, so not necessarily large, expensive mainframe systems. It transforms these into essentially a distributed file system. That's the first thing that I like to think of. That if you need more storage, you're just going to scale out and add more, not necessarily expensive servers. Step one, just store your data. And companies today are just accumulating data without any concept of retirement of data. All right, so it's cheap enough, let's continue storing it. Now, at some point in time, and maybe not necessarily immediately, there's a need to query the data. What does it have to tell me? And this is where these servers can act in parallel as a distributed processing system. It uses a batch-centric paradigm by MapReduce that we'll talk about shortly. Logic is mapped down to all of the servers that then can operate in parallel. They do their processing locally, and then through jobs there is this reduce process that reduces it back to a single result that then is sent back as a query or query response. So very, very different if you know internally how a relational database engine works, even with its parallel capabilities. Here it is across multiple servers for storage and processing. So I'll ask you to think, and we'll talk about this in a moment during a demonstration, because I will have some minutes to fill with conversation as some of the demonstrations take place. But latency, how long does it take for this to do its job? We'll come back to this discussion. So some of the key attributes of Hadoop is, well, it's open source. There are contributors like Facebook, Yahoo, Hortonworks. that are contributing to the open source project. Highly scalable. When you need more storage and more processing power, you just keep throwing more hardware at it. Redundant and reliable, so the distributed file system is known as HDFS, Hadoop Distributed File System, and it's got inbuilt reliability and redundancy. So should one of the nodes go down for whatever reason, it's like the RAID 5 file system. It can be reconstructed from the other servers. We'll take a closer look at batch processing with MapReduce in just a moment. A comparison here at this stage is probably helpful. So most of us would be familiar with relational database products side by side with Hadoop. When we're talking size, we're typically talking in the petabyte size or above for Hadoop, and we see that relational engines can comfortably work with gigabytes and even terabytes. From an access point of view, Hadoop is exclusively batch processing. From an update point of view, it's notable that Hadoop is really the concept of write once but read many times. It's really not structured or optimized for the manipulation or modification of data that's stored in the file system. What else can we point out? Scaling, linear. So because of the parallel processing nature, I won't say it's exactly double, but if you did double the number of servers, what you would find is, well, that's not the right math, is it? If you had double the amount of data, it doesn't mean it would take twice as long to process, is a better way of putting it. From a DBA ratio, typically, and the average is that 1 DBA per 40 servers. For Hadoop, 1 DBA per 3,000. How's that? All right, how does it work? I think animations say it best. So the first thing is just store your data. One way or another, get your data into the Hadoop distributed file system and just accumulate this in file format. Step 2, when you're ready, when it's time to query, the MapReduce can use JavaScript. And here is just a basic example. It's not important to understand the logic in this JavaScript. I think the function here is to do a word count. That might actually introduce my first demo. This code then is compiled and then it is sent down, and each of the 4 nodes in the server will do its processing. And then via the reduce, it brings back a result that could be made to look good with some type of visualization. So in simplistic terms, this is how this batch processing takes place. Are there any questions at this stage? Okay, let's move into a demonstration. I like to refer to this one as the hello world for Hadoop, if you've ever done programming. So this is one of the most basic, and in fact a sample that you can work with Microsoft's HDInsight. So I have a couple of servers here. I will confess up front, because of the late notice of me coming on board, I'm working with HDInsight that I'm about to introduce, but I'm working on a developer local version. Microsoft's implementation for big data is with Microsoft Azure HDInsight in the cloud. And I'll point this out to you, but my demonstrations today will be based locally using a server that's there for developers to enable them to develop logic and test it, and then they can deploy it. So everything is local. I am going to launch this dashboard experience. And switching to the interactive console, I have the ability to work with JavaScript and with Hive. And so what I'm going to do is show you that there is a file already stored in the file system. And let me just list that out. And we'll find that the sample that comes and is available to you is the davinci.txt. It's just this massive text data sitting in a single file. And I'm going to use Pig to transform this, and we'll talk about Pig in a minute, to make some sense of this. Give some statistics. What are the top 10 most frequent words that are found in this file? So what I'm going to load through the put command is I have this word count. There's the JavaScript that's going to be used for the MapReduce process. I'm going to upload that to the file system. And then I'm going to show you the content of this. And again, it's not important that we understand the logic, but there's a map function here. It all works with key value pairs. It breaks our data down into this format. We have a map function here that is responsible for the processing of sifting through all of the words, and we have the reduce that consolidates If there were multiple nodes in the server, it would consolidate all of the map jobs into a single output. All right, so how does this work? Next, I'm going to use a snippet. Using pig, from the folder, it's going to use that word count script, and then it's going to perform transformations like ordering, taking a top 10, and then outputting to a file that will be DaVinci top 10 words. Let me copy and paste this in. And away goes the job. And here I'm going to open up the log to show you there's all sorts of things that are going on under the covers. Lots of jobs and schedulers taking place to coordinate activity across potentially hundreds or thousands of nodes. This is going to take about 2 minutes just to do this operation. And you might think, well, why don't we just put that in SQL Server? We could have done it much faster. Yes, you could for that small volume. This is the trick or the problem you have in a 75-minute session is how do you practically show a real-world big data query? You'd be waiting here several hours in some instances, and I don't think that's the best use of all of our time. So what I think is a good use of the time right now is to consider latency. And I know that this is an important requirement when delivering a project for business intelligence, is that humans have limited patience. And what do you think is the number of seconds before someone really gives up, either in frustration or in trust of what's being delivered to them? Are we talking minutes? We're talking seconds. What's your suggestion? 5 seconds? 8. Well, I used to say between 5 and 8, but more recently people are becoming, for some reason, more impatient. So it's somewhere between 3 and 5 seconds. So if we were interested in the top 10 words from this book already, we're given up. Okay? And this is going to be one of the problems that you'll have to work around, is that if you do need to store or process data in big data platforms, then you're going to have to deal with latency. So as a business intelligence practitioner, I know how to deal with this already. All right? So cubes, data models do this by pre-caching. And that's okay. We can, at an off-peak time or early hours of the morning, we can process against big data and load them into data models. So if we want high responsiveness from our data, then we're going to pre-process and cache the data in advance of user requests. 70% complete. 80% complete. Are there any questions at this stage? Yes, one question up front here. So let me repeat that back for the benefit of the others and people that may be listening to a recording. Am I implying that the best way to work with big data is to store it in caches for users to query? If that's your reason for a project, if your reason is to deliver business intelligence back to business users, then you have to think about responsiveness. Not all big data, and perhaps not even the majority of big data projects would be involved in direct delivery of data to business users. Okay, so if it's data mining activities that are producing data models of patterns, these could process for days and days, and eventually their output is a model that then would form an input to some other task, a recommendations engine or something like this. Okay, so not necessarily. Don't take it away. My bias is very much on business intelligence because that's the side that I come from. But let's not overlook the discipline of data science and these new class of professionals that are becoming very much in demand, by the way. So highly educated in mathematics, statistics, very curious about data, probably don't have a lot of a social life. And yet these people are becoming very much in demand because there's a shortage of them now that there's this new technology and a growing demand for deeper insight from data. These type of people wouldn't necessarily be concerned directly with driving and delivering business intelligence insights to users. So they have a different perspective on it. Okay. Do we have a result here? I think so, and I like the fact that at the very end of all of this, all that matters is that I've arrived at some form of success. So switching back to the script console, let's make some sense of what's been read here. Let's create a variable file, read from the DaVinci top 10 words. And there they are. Not surprisingly, being right at the top. So there's the top 10 words that have been retrieved via the MapReduce logic. We can do some cool little things here in this console by taking the data and parsing it into these two columns of these types. Count of type long. So there are the 10 words. So when we talk about key value pairs, here it is. The result that comes back is a key and a value. And then we've got these cool little visualizations. Let's have a look at that as a bar chart. Let's have a look at that as a pie chart. Very 101. The hello world of big data is counting words from a text document. When it comes to Hadoop, it's really a family of many systems. So what I've described to you is the distributed file system with HDFS and the processing with MapReduce. This is the very heart of big data with Hadoop. Scripting with Pig. I just gave you an example there of scripting to order by, and take a top 10. We're going to talk about Hive as well. Hive is a good one for me because this is allowing you to create table structures on top of masses of data in file format, where that data has some sense of structure, whether it's tabular or closely tabular. We can then start to query it by using very familiar statements like SQL. It's actually HiveQL, but it's based largely on SQL. So it's very comfortable for people to work with, and perhaps big data is not as daunting as you may have thought. So there's metadata, there's graphing, there's statistics processing when it comes to data mining, there's machine learning, and they're very colourful and imaginative with the names that they assign to these different systems. Like Mahout is actually Hindi for elephant trainer. It's actually a nice one. Hive, of course, like the beehive, and then there's Stinger, and there's Pig, and then we see from the Microsoft world, PowerShell and .NET programming can be put on top of this, so developers can use familiar development skills to produce big data solutions. We then have integration with ODBC, as I'll demonstrate. SQL Server comes in here. Business intelligence I'll demonstrate on top with ODBC and Hive against big data and a Power BI story. And then Uzi and HBase and Flume and Azure. And then we can't call it PDW anymore, APS and Polybase. So they all sort of work together at some level. It doesn't mean you're working with all of these. They all have particular specialties. What I will be focusing on today is definitely HDFS, MapReduce. I've shown you Pig and Hive, and then the ODBC connectivity. All right, now let's talk about what Microsoft are doing in this space. So introducing HDInsight. This is Microsoft's 100% Apache-compatible Hadoop distribution. It's available as Microsoft Azure Service, and whoops, that's out of date. Presently available in developer preview. Sorry, in haste to put together some content that should not be there. It is in full release. And it's about empowering you guys to store and to process larger volumes of data. Now, Azure, as you're probably aware, is cloud-based. Microsoft do not have an on-premises big data solution for you. What I am demonstrating as a reminder is using HDInsight Server, which is there for development reasons, and great for demo if you don't want to depend on the internet for demonstrations. What this will mean then is that your big data and your processing of the big data will need to be in Azure. Okay, if you're looking for on-premises, then Microsoft would be happy to refer you to Hortonworks, who they're in collaboration with for HDInsight. And Hortonworks do have a Windows implementation of big data for on-premises. But when you think about Microsoft's decision at this stage anyway to be exclusively with HDInsight Azure, is that you've got the benefit of cheap storage that's elastic. All right, you don't have to have your own data center and the expertise to drive this. You don't have to consider when I need more disk space. Just as you need it, take it, and you'll be billed for it. And unquestionably at a rate far lower than what you could per gigabyte achieve on premises. All right, so Microsoft have taken this decision that big data for them means Azure in the cloud. So it's in the cloud, delivers insights through Excel, deployment agility, development with .NET and Java, built on Hortonworks data platform, and can be automated with PowerShell and the command line. So at this stage, let me switch across and show you what the Azure portal would look like if you were going to use big data in the cloud. So what I have here is my Azure portal, and I'll just give you a brief demonstration that the way I would set this up, I could come in, I would create a storage account, and the storage account is where I would have my data. And the storage is used for your data that you're storing and processing, but also HDInsight has its own data requirements to store. So that's where the storage comes in. Next, switch down to HDInsight, create a cluster, and with a quick create, I could do something like, TechEd North America 2014. How many nodes am I looking for? Now this is a quick create, so that's only 4. The custom create would let you create far larger servers. Password. What storage account will it be using? And away you go. And up in the cloud right now, it's spinning up this implementation for me. I will be sure to drop that by the end of this demonstration because it's costing me per hour. And so that's important to understand that while your data is relatively cheap, the compute is relatively expensive. So you fire it up when you need it, you destroy it when you're finished with it. This can all be automated with script. Is that a question in the back?
Yeah, you had mentioned earlier that HDInsight has its own storage requirements.
Yes.
So if I upload or put the data set that's inside of the storage container, is it then going to distribute that same data through the HDInsight so I, in essence, have 2 copies of that information?
I heard most of that, and so I think just let me repeat back anyway for the audience. So you've got your data, and then you've got metadata that the service is using? Nope. Could you start that again?
You bet. So my understanding is HDInsight is a Hadoop instance, right?
Yes.
Okay. If I upload data into Azure, into my storage container,
Yes.
does that data then have to be pushed onto the Hadoop compute resources, therefore having 2 copies of the data?
Right, no. So what you would have, there's the storage for HDInsight itself, and then there's the storage that you would be processing against. They don't need to be the same. Okay. All right, so that's as far as I'm going to show you with the cloud. It's just a little impractical, especially at last minute, to come up with some demos. So we'll come back to further discussion. So what does this mean for us when it comes to the traditional flow of data? So in a traditional sense, we accumulate data in operational systems, whether it's CRM, ERP, and so on. And then the common approach, and certainly the tried and tested approach using the technologies at hand, have been to extract, transform, and load, and get that into a data warehouse as a clean, credible platform for data that's conformed, integrated, and ready for business users to, with confidence, start answering business questions. Log files, though. What would you do with the accumulation of log files? Well, keep them, and then we might ETL some of it if it's relevant and discard the rest. The newer approach could be don't throw anything away. It's just so cheap to keep everything, and it would be a shame to drop something to find that later that could have been valuable. And especially with business intelligence, we love to see trends across time. So we don't want to lose the fact that we've got history of 10, 20 years ago now. So what we could do is just store this in Azure Blob Store, just accumulate it, without even the intention today to think that we'd be processing it with HDInsight services. Okay, so that's the new approach. Just store it anyway, and at some point, that could be useful for a number of reasons, but from a business insights perspective, you've got it there. And then you can just fire up a cluster, send off a job to query it, bring back the essence of it to answer your questions. All right, so that leads us into the next demonstration, Hive. Being able to build this table structure on top of data and then query it as if it were a relational structure. So in fact, I'm going to switch back to I'm working on two machines, and I'll describe this. The first machine that I demonstrated, I'm going to switch back to, is my HDInsight server. And so this time I'm going to move to load some data. Let me show you the data first. It's very, very simplistic. Weblog information at AdventureWorks, they have 4 weblog files spanning 4 years. Automatically you see this is not a candidate for big data. All right, so just imagine that there's really 4 million files for 2005. Let's just take a look inside. And what I've got here is CSV. So this is a very convenient example, I will confess, but I think it's easier to talk and demonstrate with this type of data in that it's completely tabular in structure. We have no header, but we have the IP address, we have the authenticated customer, we have some session identifier of which you can see 2 requests have been logged here for the same session. We have the date and time stamp, and then we have the request. Following the request, we have the HTTP status, 200 being an OK, and then the number of bytes. So of interest will be that if we're logging a request for the browse page, in the query string we can actually work out what product they were browsing to. So we're going to use this for some analysis to understand who with the authenticated customer, when with the timestamp, and then the product, and then see what we can learn from this. So with very, very simple, having these 4 files, I'm going to copy the folder path to the clipboard and switch back to the JavaScript console and load this data in. So, have all of these commands available. The copy from local is going to be very useful. I can pass in a folder path and it will upload into the file system the content of the folder. Copy from local, from that folder to the data folder. Now if I list what's there, there should be something there. To data, okay, maybe, I've got to remember my notes on this, /data. Refer to my snippets. Didn't I get it right? Data weblog is a directory. Okay, well show me what's in data weblog. No, it did it. I just had the wrong command. I had it the wrong way around up here. So there's the 4 files now sitting in the distributed file system. How would we query them? Well, you could cut some code with JavaScript, but why would you when it's structured in the way it is? It's CSV. And that's where I'm going to switch across to the Hive console. And we're going to create a table structure on top of these files in the folder. And the table structure is defined here with a create external table. And I copy the command in and let me read out what it's doing. It's creating an external table that is named weblog that consists of these columns. IP address is a string, account ID is a string, everything's a string, even the date and time in this version of Hive. And then it describes the content, and then it locates where the data is stored in this location of the file system. And so by evaluating this, it creates the table structure, and then we can start to query it. This will take 2.3 seconds. Let's just query some metadata about this table. Let's have a look at show table extended like weblog. Okay, and of interest here is that this table represents 4 files. Realistically, in a real-life situation, it could be tens or hundreds of thousands of files. That when you're querying this table, you're really querying across the file system. Next, let's simply count the number of rows that are found across all of these files. And this is where we go off and get a cup of coffee. All right. Even though there's 4 files, the overhead in firing up the jobs and the schedulers to do this do take time. Okay, it's not scaled for small data. So this is going to take about 30 or 40 seconds, and that's where we say a business user at this point isn't going to be too impressed with that. And so where this demonstration will head is that we could use big data just as another data source. So when it comes to an ETL that we typically query from Oracle, SQL Server, and now we could just query from big data. It's just another source. And so we often refer to the concept of taking big data and making it small data. So we've got the ability there to transform the data by using a group by in Hive. We're only interested in minute summaries of what's gone on, not every individual request. And let's summarize down to something that's actually much more practical to retrieve, store, and then analyze. So this example is really about making big data small data. And we're going to use this then to load into a fact table. Question?
Yeah, on the latency, is that MapReduce job on that last one going through all of that, or did that have to create the table?
So the question is about, well, what's going on? When I created the table, it's just a metadata description. It's just logged into the metadata catalog. And now when I actually run a Hive query, such as give me the count of all rows in the table, now it's firing off under the covers MapReduce jobs that have been written based on the query that we wrote. So this abstracts you entirely from any JavaScript.
Okay, but it goes back down to the actual log files and does that count?
Indeed it did. You see all of the statistic here are jobs that were reading the data from the file system and that JavaScript logic that was doing what it needed to do. And then bringing back those results to be reduced to give us this single result of there's 100,000 rows. That's what was involved to produce that result. So let me finish off with one last query, which is and look at the familiarity here. From weblog, it's just a table. Give me these columns and a where clause, specifically testing that if it finds browse.aspx in the URL, then we want it. We're only interested in successful requests, and therefore we can extract the product ID from the URL if this condition is true. And then finally, a time filter here. In this version of Hive, they don't have a date timestamp, so we just have to use a string. So the left 4 characters, if they're 2008, that gives me all the 2008 browsers, and it gives me date, account, session, and product. And that'll be exactly the query we're about to execute from integration services. All right, so that's the topic of Hive. I'm now going to switch across to another server that is going to connect and via ODBC is going to query. So back to my development machine. The first thing that I'm going to do is install the Hive ODBC driver. You can download this at no cost from Microsoft. And now that that's installed, I will come and define ODBC a data source name. So when I click Add, there is the Hive driver. Click Finish, and I'll provide it a name. And the host here is, because it's local using the developer version, it's just HDInsight. For Azure, you would be using the URL to connect up to the service in the cloud. And you would be using fairly strong credentials. There are no credentials when working with HDInsight Server for local testing. Now that that's been developed, let me switch across to Visual Studio, where I have an integration services project already defined with a package to load a weblog table. This weblog table doesn't yet exist. I have a script here that is going to create in my AdventureWorks data warehouse a new fact table with a date key, time key, customer key, product key, and the session identifier. And then to integrate it with the rest of the data warehouse in this very small sample unrealistic data warehouse, I'll use foreign key relationships. And now that I have this table, we're going to populate it with integration services based on a Hive query. The project already includes a connection to the target with the data warehouse. Here for HDInsight, it is using that data source name. The design of this package then, okay, remember it's simplistic. We're working with years, and there's a parameter here that says, what year are you processing for? Collect that in the year parameter. A SQL task here is going to delete any rows in the fact table for year 2008. And then here it's the data flow task. And if you notice in the top left corner of the task, there's an expression icon here. So there's an expression that is dynamically building up the Hive query. And here it is here. It's a little hard to see, but that is the valid Hive query, and it's simply concatenating in to that where clause, the 2008. So this is precisely the query that I executed in the other machine. Okay, my screen is just frozen for a minute. Let's see what's going on. There we go. So looking at the data flow itself, here it's an ODBC data source that's using that expression, the valid Hive statement. Then it's just standard manipulation of the data, lookups against surrogate keys and dimension tables. Let's just go ahead and execute this. So now when you think of what's going on with the integration services on this server, processing a package, it then creates a connection by the data source name, sends a HiveQL query across to my other server, which is using Hive that internally is using MapReduce with JavaScript against potentially thousands of files. Or the realistic example with HDInsight, this is all happening up in the cloud. So big data can be just another data source. And now we see some success with some 38,000 rows of data loaded into the data warehouse. Let's just take a look at that. Drink. So you can see this just integrating with your standard ETL processes. Any questions about that? That's integration services, ETL, and working with Hive. The Hadoop data flow. So we have data coming in at an extraordinary rate and extraordinary volumes. We can use Hadoop for storage and for processing. Hive is a really basic concept when you think about it. It's just treating the big data platform like it were a relational store. And then we can build analytics on top. Okay, so that leads into the next demonstration, self-service BI with Hive. And so this happens in a number of ways. Have you seen any Power Query sessions this week? So if I launch Excel, in fact, I already have it launched. Let's open up another instance. Doesn't look like I have Power Query installed. I may have overlooked that. Nonetheless, I wasn't going to demonstrate it, but Power Query has the ability to query with the HDFS and the Azure Blob Store direct. Right, so there is a connection between Power Query getting involved with big data, but where this demonstration will head is the Power Pivot story. So when I manage this workbook data model from other sources allows me to create a connection using ODBC. I can build up the connection string based on the data source name. And then because it regards this as a relational source, you have a choice. You can import from tables and views from the source, or you can write your own query. Now it's interesting that when you go to query the tables, the catalog tables are instantly retrieved, and you can even preview and filter, and this is just raw data, no processing, just flowing through. I've learned the hard way that you want to be very careful about using this drop-down list, which provides you the filter options. In other words, the distinct values found within a column, because then that's going to fire off a distinct query that will take literally minutes, if not hours. So do not do that, especially in demonstration. So I cancel this. When I switch back and choose the other approach, this allows me to submit a HiveQL query. And this then will become my weblog table. That is the HiveQL that I had from the other server. And now when I click Finish, here's self-service BI analytics taking place on top. Now this Hive query doesn't do it, but group by and where are going to be pretty important. So some of the things you're going to do to make big data small data would be to aggregate it, would be to reduce dimensionality. You can even use techniques to sample. Maybe just give me 10% of the data, and if it's a random 10%, we can augment the responses by a factor of 10 to come up with a representation of what that data means. Okay, so there's various techniques that you could employ there. And so it didn't take too long for that to come back with 38,528 rows, and then it just becomes a standard self-service project. So let me develop this just a little further. Date and time, account, session, product. So I know for date information that I've got a data service internally that gives me corporate date and corporate time. Let me take this data service and show how we can integrate big data with services and on-premises data. Let's bring in from feeds. This would be my data service. The URL is in here. And let's bring in both date and time. Date and time, these will become the names of the table. Let's start with date. I don't want everything, so I'm interested in the date key, the date. Let's eliminate this. Date key, date, month key, month. And we'll do calendar analysis, so I need calendar quarter label and calendar year label. For the timetable, you'll see that in this table there is 1 row per minute of a single day. 60 minutes within 24 hours. So note the time key here is that at midnight it's 0, and it's basically the minute and what happens when the hour clocks over. I can't show you, but it would be 1:00 for 1 a.m., 1:01 for 1 minute past 1. So let me load this data in. And then switching back to this big data, I've got a date and time here. So I'm going to switch this from the text as it was retrieved from Hive and switch it across to date. That would allow me to add some calculations in here, like if I take the year of date and time and multiply it by 100,000, and then add to it the month number from the date and time and multiply by 100, and then add the day number, you end up with the numeric key value for that date. I'll rename this across to date key, and then do the same thing for time, equals the hour found in here multiplied by 100, and then plus the minute of this. There's my facts and information coming from Hadoop, and then I have this date key. So we'll relate it to the date key, we'll relate this to the time key. And I'll just continue on a little bit more to show that the rest would be on-premises data. So this is not an unusual situation, big data colliding with on-premises data, and you see a good example of this with the PDW, or now APS. So with its polybase, it is enabling you within single queries to query across the relational data that is stored and then across to big data simultaneously. So here in the warehouse, I've got information about customers and products. So I'm going to bring these in as queries. For the customer, what's recorded in the web log is the customer code. So if I come to the data warehouse, I'll find that I've got a dimension table and I've got the customer key here. And I've got attributes like first name and last name if I want that detail, which I probably don't. What's of interest is that I've got geography key classifying the customers, and that gives us a concept of where they're coming from. So via relationship, I can bring in state, I can bring in the state province name and the English country region name. And that results in a set that looks something like this. I then like to rename this a little bit, so this just becomes the state column, this one becomes the country column, and then I've got warehouse data coming in as well. Customer key maps to account ID, or it should do. Customer key, you know, I got that wrong. Easy fix. It shouldn't be customer key, it should have been the alternate customer key. And if I name that account ID, alternate customer, alternate key. Okay, I'm a little bit rusty when it comes to AdventureWorks terminologies. I thought it was alternate. Customer alternate key. All right, then I'm in a position to relate the two of those. Let me just do that quickly one more time. Existing connections, open up the data warehouse, and again, a query this time for product. And as a snowflake dimension, I'll just quickly build up a query across 3 tables, starting with the product itself and its alternate key. Surrogate keys aren't being stored in our web logs. English product name related to this subcategory table. I have the subcategory name. And then the category table with the category name. Now, importantly, because this is type 2 changing dimension, I'm also going to do some filters. I'm only interested where the product is a finished good. So there should be a flag for this. So filter. Finished good is true. And the status is current. I only want the current type 2 versions. If I don't do that, by the way, you'll end up with duplicate product keys, and Power Pivot doesn't support many-to-many relationships like this. There must be a one side of the relationship. Okay, so that results in a set of my products with a key that can join to what was found in the query string of the browse page request. Okay, and that's how you can integrate big data and local data. Any questions? Self-service BI with Hive. Moving on with Hadoop capabilities, we've looked at the ETL, benefiting from distributed compute. Well, whether it's ETL or mining, anything's going to benefit from distributed compute, but we're really leaning towards the power of mining. And so predictive analytics with forecasting or clustering or association analysis, machine learning, graph processing. So there is a huge surge in interest of mining data and using algorithms across data in big data, and as a result of this, there's a huge investments being made to contribute to the projects like Mahout and to increase their libraries of functionality. So some data mining algorithms looking for similar items, looking for across streams of data and making sense, like network intrusion is an example of this, making sense of streams of data as it passes through, link analysis, frequent item sets, so the market basket analysis and what Amazon can achieve. Those that looked at this looked at that. I have a demo on this quickly shortly. Clustering, so looking for like groups within data. Advertising on the web, recommendation systems, and social network graphs. So all of these capabilities are on the rise and are being improved over time through big data. Mining streams of data, I've already talked about this one. Finding similar items. I love the icon here with the guy that's looking for his or her partner. Similar web pages. Plagiarism, in fact, is something that big data can address as well. Let's take a look at frequent item sets with market basket analysis and how we can use frequent item sets to go ahead and understand the relationships and strengths of relationships of what people are buying at the same time. An adaptation of it for this demonstration is what are people browsing at the same time? So when you see those recommendations come back from Amazon, they're not necessarily what people have purchased, they might be what people are browsing within the same session. Okay, so let's see how that could be done. Now, this example is mining on premises, so I'll be upfront. I would not be mining this with analysis services, but I am in demo to at least give you the principle. I don't have the skills nor the time to put together a demonstration that would show you how this would typically happen up there in Azure. The concepts are similar. I'm just going to use analysis services on premises. So this will involve working with SQL Server because analysis services doesn't support ODBC connectivity. It only works with .NET managed providers and OLEDB. And because Hive is ODBC, the solution that I have is to create a SQL Server linked server and expose the data through a view, and then I can use analysis services to query these views. And this is how it will work. So as the DBA, I can come in and here under server objects, under linked servers, I have the providers. This is the provider here, which is the OLEDB for ODBC. And there's one thing that I need to do, and that is enable the level 0 only. I don't really know why. This isn't well documented. It says you just need to do this. So I know that it works when I do that. But be careful that you don't have other linked servers using that provider and that it may well affect them. The fact is that I have no other linked servers, so I'm comfortable to make that change. I then create a new linked server, which I'll name HDInsight, and then select that provider, which is the provider for ODBC drivers. The data source then will be HDInsight, the name of the data source name. And now I have this ability to query direct in line with my T-SQL statements. So I'm going to create a couple of views. Let me just run this immediately. Go and give me the distinct session IDs from my linked server ... to the Hive table name. That query is remarkably fast. The second one is giving me the combination of sessions and models. So I'm not interested in actual product level. The fact is we might have tens of thousands of products and it's far too much detail. What we typically do is generalize up. Instead of Coke in size 1 litre and Coke in size of 2 litres and Pepsi, we might just generalize and say cola, right? So here I'm doing that by saying just give me the model name, and here are the distinct combinations of sessions and models. So really this is about what models were browsed at the same time. So I create two views. And while that's happening, I switch back to Visual Studio and I introduce a new project to my solution, which will be of type analysis services. This will then become weblog mining. I start by defining the data source, which is now SQL Server, acting on our behalf for Hive. Next, define a data source view. This is a virtual schema representing the data that in this case will be mined. And the two views that I've just created are available here, the session and the session model. I'll call this session models. Takes a little while to think. It's actually retrieving the metadata for those views, like columns, data types. And clearly, it's going down to Hive to do something. I'm not exactly sure what. Provide some more friendly names, like this is the session, and within the session, there could be one or more models browsed. So I'll call this the basket. I'll define logical keys. In fact, these two, because they're the distinct combinations, are keys, and then I can create a relationship. A session has multiple models browsed. We're now ready to mine this view by creating a structure. The data is coming from relational, well, not really, but analysis services will be using that. Then we'll use the association rules, which is for market basket analysis. It wants to know which data source view. And next, where is the case? So the case is the session itself, and nested within the case would be the models that are browsed. So it's interesting what it does here, because it will take all of the distinct models and pivot them to the columns. And so every row within this set will represent a single session, and across all of the models, it's either true or false, that that session included that model for a browsing purpose. And that's what a nested structure will do here. With that defined, the key is the session. The model is also key within the basket. It's an input, and we're looking to predict it. That's just the way it gets configured for the association rules algorithm. The next step within the wizard wants us to define content and data types. These are well understood based on SQL Server data types. There's no need to change anything. And do we reserve any data for the purpose of accuracy testing? And for this algorithm, there's no need to do that. What the association rules algorithm is doing is counting frequent item sets. And it will first look at the single models, then what is the combination of these two models, how often were they browsed, these three, these four, and it just continues until it's exhausted the supply. When it has this set of all combinations of models and the frequency in which they were browsed, it can then use statistical techniques to generate rules. And those rules are the association rules that we can apply to understand the associations between models. So, no data to be left out. We'll name this the web log mining. Click Finish. This structure has a single model defined. That was what the wizard created. The algorithm parameters allow us to fine-tune what the engine will do. I'm going to make it super sensitive because I really don't have a lot of data. You'd want to be careful playing and tweaking with these. They could be the difference between processing or never finishing to process if it's looking for very, very subtle rules. So with that defined, deploy, that scripts up the definition, sends it to the server, instantiates by creating a database, data source view, structure, model, and the default processing option is to process. All right, so what it's doing right now is the Hive query. It's bringing the data back, so the mining is actually happening on the analysis services server, not in the cloud. And then we have the visualizations on top here. All right, so the first one is really the item sets. For each, in this case, size 1, a single model. And let me turn this to just the name. So Sports 100 was browsed 7,691 times. A little more interesting to move up to the 2 size sets. The mountain bottle cage and water bottle were browsed together in a single session 1,998 times. And we'll find the maximum item set size is in fact 3. Bottle cage, mountain 200, water bottle. Based on all of these frequent item sets, the rules are then generated. So in descending order of probability, and this is a little suspect, Turing 1000 and water bottle would result in road bottle cage being browsed as well 100% of the time. Okay, this data really came from sales transactions, not browsing. And that would tell somebody they're actually sold together as a unit. If it's 100% of the time they're bundled together, you have no choice. Let's look at something a little more realistic with our story of browsing, like if you browsed a water bottle, there's a 36% chance that you also browse the road bottle cage. What about this one here? The mountain tire and the tire tube, 43% chance you also browse a Sports 100. So this is nicely visualized by using the dependency network. And if we just focus on something like the bottle cage for the mountain, we can see here that the selected node, the mountain bottle cage, via relationships, water bottle, mountain 200, the purple says they predict both ways, that water bottle would predict that you would browse to bottle cage, but also bottle cage would predict that you would browse to water bottle. Not so with the Sports 100. The bottle cage does predict Sports 100, but not the other way around. And as you slide down, you can see the weaker relationships drop off. And this is very useful for people to understand how best to bundle things together. Certainly in supermarkets, product placement is a huge science today. And that's the technique that they would use, albeit using more robust and scalable engines. All right, and that's where the association analysis and frequent item sets in the cloud and with big data is a much more interesting scenario. It needs a lot of grunt to be able to assess these frequent item sets, and you're limited here with analysis services to a single server to do this. And Amazon, for example, would not be considering a single server to do that type of processing. Any questions about that demonstration? Okay, well that's pretty much arrived at the end of what I need to say and my demonstrations. Where we wrap up with a summary is that data is big, small, it doesn't matter. Whether it's small data that's practical and economic to continue to store in ways that we've mastered and perfected, the story continues. If it's large sets of data, whether it's large, whether it's a variety in structure, whether it's just the velocity of it, you may well consider storing it at low cost, even without an idea of how you might use that data. So the first thing is just retain the data at this stage. At some point, it could be useful and contribute to knowledge. And you've learned that the techniques that we now have for working with these large sets of data stored is through distributed processing. And there's a whole ecosystem out there that can allow you to discover insights from this data. So what we'll have you think about is it's likely that you do have big data. You may not be aware of it. You're definitely capturing outcome data like sales, transactions, and manufacturing statistics and so on, and likely capturing ambient data around this as well that you might be quick to dispense with. All data, whether it's outcome or ambient, has some value, and today's challenge is about unleashing that value from any data. And that's where Microsoft Azure HDInsight can address these challenges with storage, with the Azure Blob Storage, and processing of big data with Microsoft Azure HDInsight. Power BI has a role to play here as well. We can connect to and query big data. We can make big data small data, and I don't think it'll be uncommon in years to come that analysts will be out there connecting direct to and consuming big data results. SQL Server can also connect to, I've shown examples with ETL with integration services, data mining with analysis services. We just see that big data is just another data source. All right, Microsoft have a case study here that might be of interest to you, actually using analysis services cubes. So Clout, as an organization, are there to measure influence. And so, for example, if I check in at a hotel, that hotel may subscribe and pay for Clout information that would inform them that I'm such an influential person, they should upgrade me to the penthouse suite. How does this happen? I'm not exactly sure how it happens, what data they use, but the value add that they have is that they can take masses of data and they can distill it down to a single score assigned to an individual, and that delivers value to organizations like hospitality and so on. They delivered a solution by using Microsoft Big Data and analysis services with cubes, and this case study is available for you. That's the last link here on the resources slide. I leave you here with the resources for Microsoft Big Data website, Microsoft Azure HDInsight. I often get the question about, well, how can I learn about big data? This sounds cool, and it sounds like there's really good career potential, and I would suggest, yes, there is, if you have the aptitude. Hortonworks, and they're here at this event, they have tutorials and also a sandbox that you can download that allow you to work through big data activities if you want to learn about Hive, if you want to learn about Pig. And so I'd strongly encourage you to explore the free resources that you have available there with their tutorials. That's arrived then at the end of today. Are there any questions before we wrap up? Thank you. Yes? Right, so your question is what I then demonstrated with analysis services to bring back some mining results and some predictions?
So, it sounds like if you're doing a lot of that processing, wouldn't you want to do that on the cluster?
Right, exactly. So the point here is if we're doing a lot of processing, especially heavy crunching, which is involved with frequent item set counting, yes, if I've got large sets of data, I would want that to happen in a distributed platform. So it's a perfect fit. Doing this on a single server will not scale. The expense to scale it up to achieve this would not be worth it. You'd want to look at the the scaling out with Hadoop.
So that business intelligence project that you used, was that doing the processing on a single server, or was that doing it on the cluster?
So the demonstration, the questions about the demonstration that I did with the association analysis, that was querying the data and bringing it down to analysis services. All right, so if it was a true cloud implementation with HDInsight Azure, it's bringing down all of those rows of data. This is not a good thing to actually do. For demonstration with a small set, it's just showing what could be achieved, and that similar algorithms, yet more scalable using the MapReduce paradigm, can achieve this across your big data store. Okay, so it's really there to give you the idea of what could be achieved, but please transplant the example to up there. However, I'll just make the note that if you do distill to a small set of data coming down from big data, it makes perfect sense to continue to use familiar and tools that you may already own. One other question over here.
So we use HDInsight for POC for stream data for HDFS cloud-based technology, and our biggest headache was the documentation was very sparse. So Amazon, which has last MapReduce, and their documentation is great. But because if we wanted to go in natively and schedule busy jobs or workflows, it was really hard to find how to do that.
Okay, so let me share this back for the others and for those listening. Someone in the room here, proof of concept, working with HDInsight, has said that the challenge with it was lack of documentation and having to find things out by trial and error, I guess. Yeah, I've been involved in some training activities around getting developers to learn about what big data is and how they can produce big data solutions. And I can tell you that the guys that put that training content together had a similar problem trying to find this. So I think that's something that would help to go back to Microsoft about and say, listen, this is a genuine concern. We're interested to evaluate your platform, and yet it's very, very difficult when you don't provide us enough resources. If Brian was here as he was scheduled to give this session, he would have some pretty great advice, I'm sure. And so I have included his details with Twitter handle and his Microsoft account. If you don't find someone here at the event this week to help you out with perhaps the information you're looking for, or at least to lodge that feedback, please reach out to Brian. Okay, if there are no other questions, let's wrap it up. Classic resources and standard resources. Please, if you would take the time to complete an evaluation, we'd appreciate your feedback on how this has helped you and how perhaps we could better help you in future. There's the QR code. I will thank you for your time and attendance and wish you all the best with your big data adventures. Thank you. Big data in our solutions. So we'll introduce terminologies like big data, Hadoop, and Microsoft Azure HDInsight. We'll describe what the big data process is, how it happens. We'll see it happen in a demonstration. We'll talk about various big data scenarios and hopefully inspire you with what you may be able to achieve with your own data and big data technology approaches. So let's start with the very intro. What is this all about? Why do we have a new way to store, process, and query data? Well, the fact is, we are all contributors to this mass collection of data, whether it's our tweets, our Facebook entries, our phone calls, our very presence even here in this room is being recorded somewhere. And the fact is, we're recording larger volumes of data than ever before, and what that means is there is new opportunity to discover insights and to do things better. So whether it's device explosions, social networking, sensor networks, ubiquitous connections, and in combination with cheap storage, we're just storing it these days. It's less likely to find that DBAs are concerned with archiving data. It's now inexpensive to continue to storing it. Whether we know we need it today or not, to lose it, it's irreplaceable if we do go ahead and drop that type of data. So even with the recognition that maybe we need it, we're usually happy just to continue storing it. So this introduces an entirely new challenge when it comes to the storage and querying of data. And when I go to Wikipedia to get a basic definition, this is what's come back. Big data is a collection of data sets that are so large and complex that it becomes awkward to work with by using on-hand database management tools. So the old way of doing things may no longer be practical, or most likely no longer economical. Difficulties will include the capture, storage, search, sharing, analysis, and visualization. And that's where I come in, the last two. How do we analyze and visualize masses of data? And how do we discover insights even before we consider visualizing them? So when we talk about big data, it's very common to talk about the 3 V's, beginning with the most obvious. Big data lends itself to an understanding of big volume. So sheer amounts of volumes staggering compared to what we were doing even 10 years ago in terms of storage. Variety. So data doesn't always come in convenient tabular format. That's a shame. All right, so we have all types of structure, whether it's hierarchical or even whether it's just lots of ones and zeros, binary data. Nonetheless, it's data, it's been captured, it's been stored for a purpose, and it opens up the challenge for us then to make sense of that. Traditional database products struggle at this point to work with non-tabular forms. Velocity is the next consideration, that this data, by definition, if it's big data and we have large volumes of it, it's probably being accumulated at a fast rate. Is that a fair deduction to make? At this case, it means that the data could be coming at you so fast that it may be impossible or very expensive hardware-wise to be able to capture that as it's happening. And so Microsoft already have a solution for this before we even think about big data. What do you do when you have such large volumes of data coming at you at speed and yet you need to make sense of it? Anyone heard of complex event processing? HDInsight is Microsoft's implementation of a complex event processing engine. So what you can do is streams of data, you could capture windows of it and summarize it every second. That's the average that's coming through. So you could use complex event processing to go ahead and make streams of data practical small volumes to store. But the point that I'm making here is the velocity angle may well lend itself to a big data scenario as well, as we'll talk about in this session. So there's the 3 V's that are commonly used to introduce why we have this new way to capture and store data. Plotting here against size and storage and therefore cost, we can see here that the traditional systems, ERP, CRM, they fit comfortably still within a SQL Server instance. They might grow to the gigabytes or even to the terabytes, but they're still manageable and economic to store in this way. Moving up, the Web 2.0. When we think about classic examples, and it's always good to think of extremes, Amazon, you can even think about the number of transactions that are being processed a second. And you might automatically think, well, yes, these would be orders that people are submitting. There's actually far more ambient data that's being collected when you're visiting Amazon. Are you aware that every time you hover over something or click, or even the duration between clicks, all this data is being collected? And it's mind-boggling to think what is being collected and the volume of that data simply for that single 5-minute experience you had while shopping. So with the advent of global retailers as a great example, not just their commercial transactions, but ambient data being collected is resulting in petabytes. And moving right up to the Internet of Things, the classic would be to talk about Facebook. Can you imagine there what's going on with the volume of data? And this is the new challenge today. Different shapes of data, large volumes of data, and yet the business still has a need to make sense and to understand what that data represents. Common scenarios, sentiment, what are people feeling? We'll talk about this in more detail in a minute. Clickstream analysis, what is going on with our web applications? What is being clicked on? What are the trends from this? Sensors, time and place information, server logs pumping out volume. So it's a good afternoon and welcome. This afternoon's session on From Zero to Data Insights using HDInsight on Microsoft Azure. Welcome, my name is Peter Myers. As an announcement, this was originally scheduled to be presented by Brian Mitchell, who unfortunately has fallen unwell, and I've stepped in at last minute to help out to continue delivering this session. I have a slightly different take on this topic. My background is more in conventional and self-service business intelligence. So when I talk about big data, I'm thinking about it more in the business intelligence scheme of things. I can talk practically about the big picture, but you'll notice a focus when I talk about this, even with my demonstrations, that they're business intelligence oriented. All right, so I'm a SQL Server MVP. I've worked with Microsoft Business Intelligence products for well over 15 years. I come from Melbourne, Australia, and I'm very happy to share this introduction from zero to about big data today. So by show of hands in the audience, who here is already working with big data? Already working with big data. You come to a session that is zero to big data. The concept about zero is typically that we'll take you from zero background. You're most welcome to stay, and we'll definitely want to tell you about how Microsoft are working in this space. We're going to work with the very basics about what big data is and build up, describe scenarios, and a few demonstrations that are going to show how we could work with